static versus non-static member. So now we will discuss the static versus non-static member. So in a class, the member are divided into two types, static and non-static. The members, whenever I'm saying member, it might be a variable, it might be a construct, or it might be methods. Variable, constructor, and methods which are created by using the static keyword are called static member, and rest of all are called non-static member. Right? In a class, the members which are created by using the static keyword, they are going to be static, and rest of all are non-static members. So if you can see this example, so here I created this variable y using the static modifier, and this main method is using the static modifier. That means these two members are static and rest of all are non-static members, right? So we can also define that the member of a class that does not require an instance either for initialization and execution are known as static member. See, if you declare a member as static, then you can directly access that member by using the class. That means what it means? It means you doesn't require an instance. Instance is not required either for initialization and execution. You don't need to create an instance to initialize the static data member. You don't need an instance to call the static data member, right? So if a member which doesn't require an instance either for initialization and execution known as static member, and other hand, the member which required an instance of a class both for initialization and execution known as non-static members. That means instance required, non-static member. Instance not required, then it is a static member. Instance, why we need instance? Instance we required for initialization as well as for execution. We'll see that practically. Okay. So we have different kind of members. In a class, we have variables, we have constructors, we have methods, right? So we can make the variable as static, non-static. We can make the constructor as static as well as non-static. We can also make the methods as static and non-static. So let us discuss these things one by one. So let's start the discussion from static and non-static variables, right? So first of all, let's see the definition. Whenever we declare a variable by using the static modifier, or whenever we declare a variable inside any static block, then those variables are considered as static variable, whereas the rest of others are considered as non-static variable. Please look this program. So here we have declared this y. Y is a static variable because we created this variable by using the static modifier. And here a is also by default static. Why? Because this variable a is declared inside the static block. So whenever you created a variable by using the static modifier, or whenever you declare a variable inside any static block, they are said to be static variable. And the rest of all means this, if you are not declaring variable using static modifier, then it's a non-static variable. And if you declare a variable inside any non-static block, then it's a non-static variable. Is that clear?
Yes, sir.
Okay, now let us read some few points related to this. If you want a variable to have the same value throughout all instances of a class, then you need to declare that variable as static. So the static variables are going to hold the application level data, which is going to be same for all objects. That means, in simple word, we can say data sharing. Data sharing means if you have some value, you can say that if you have some fixed value, and if you want that fixed values to be shared by all the instances of the class, then you need to declare that variable as static. Once you declare the variable as static, then that variable will become an application level variable, and those data is going to be shared by all the instances of the class. The static variable gets initialized immediately once the execution of the class starts, that I will show you, whereas non-static variables are initialized only after creating the object of the class, that is to for each time the object of the class is created. We'll see this point practically. A static variable gets initialized only once during the life cycle of a class, whereas non-static variables get initialized to 0 or n number of times depending upon the number of objects created for that class, right? That I will also show you practically. If you want to access the static member of a class, then you need to access them directly within the same class using the directly within the same class and using class name from outside the same class, whereas you need an instance of a class to access the non-static member. Okay, let us understand these things practically. Right, so you can see, okay, let me remove this. So you can see this is a non-static variable and this is a static variable. And you can see using the constructor of the class, I'm initializing the non-static variable. You can initialize using this keyword, or even you can initialize directly. Suppose I'm writing here now, right? So you can directly also initialize like this, right? Then when you need to use the this keyword, if I write like this, then then he is going to confuse. So this x belongs to the local this class level x, or this x belongs to the local variable x. So in this case, in order to differentiate, you need to use this one. This keyword means the class level x. So this dot x means it represents this variable, and this x means this variable, right? So here we have one non-static variable, one static variable, and I'm creating this class, right? And this class, and this is the main method. Here I'm accessing the static variable using class name before object creation. See, I'm not creating any object. Okay, let me remove this statement. Without creating an instance, I'm accessing this static variable, and I'm accessing the static variable in two ways, using the class name and even directly. Even you can access the variable directly if you are accessing within the same class. The class definition start from the line number 5 and end in line number 33. So within line number 5 and 33, you can access this variable y directly like this. Even you can access the class variable using the class name. Example is the class name dot x. So the thing that you need to remember, if you want to access the static variable within the same class, you can access them directly. If you want to access this class variable in another class, let's say I have another class, I'm creating class sample, right? And let's say this sample class having some method, void some method, right? And if you want to access the static variable from outside the class, now the sample class is outside of the example class. Even you can also access this. So if you want to access, you need to make that variable as public, right? So now if you want to access this y variable here, you cannot access directly, right? You cannot access this variable directly here. You cannot access this variable directly. See, I'm getting one error. So the y doesn't exist. From outside the class, if you want to access any static variable, then it is mandatory to use class name. See, I write class name and I access this. But within the class, you can access them directly. So that is the point that you need to remember. Within the same class, you can access the static variable, not static variable, any static member directly. But from outside the class, if you want to access, then you need to use the class name. So both I'm showing here. So here I'm accessing using the class name, and here I'm accessing using the name directly, right? So this is one of the point. And the static variables are, and one more thing here you need to understand. I'm not creating any instance. See, the instance statement I have commented. I have commented the instance creation statement. Even the instance statement creation statement is commented. Then also I'm accessing this y variable, and I will print and I will get the data. See, see, static variable y, I'm getting the value or not. So I'm getting the value means what? That means The memory allocation is already done or not? So when the memory allocation is done, when the class is loaded for the first time, that I will discuss. Before executing the main method, the constructor, the static constructor is going to be executed, right? So let's open the application. Okay. Visual Studio 2017 developer command prompt. Okay, let's open the ILDASM tool, right? And where this application is created. Okay, bin debug. Yeah, this is the code. Static keyword demo. See, here you can see one constructor. So this is the constructor. So you can see this constructor is created with the some symbol S. You can see now. Have you seen this constructor, the letter S?
Yes, sir.
Yes.
So this means this is a static block, and this main method, you can also see this S, right? Means it is a static, and you can see this Y is static, but you cannot see anything in X or this CTR. So what is this CTR that I will discuss? For this X, this is a non-static, so you cannot see find that S symbol here, but Y it's S. So if you look at the Y variable, it is static, and if you look at this is the public integer constructor, right? So you can see, so this public static int, so this is a constructor. So this is, so whenever you are seeing CTOR means it's a constructor, right? So CTOR, it is also a constructor. It's a void constructor, means this constructor does not take any parameter, and this is a constructor which is taking integer parameter. But in our application, we have only defined one constructor which is taking one parameter. That means this private this static constructor is automatically given by the compiler, and that constructor is the first block of code in our application to be executed, right? Whenever, yeah, after some time I will discuss how it is executed before executing the main method, but for now just remember this is a static constructor. This constructor is provided by the compiler, right? I have not defined any static constructor in my application, but this constructor is provided by the compiler, right? And this constructor is basically used to initialize the static members. So you can see, as part of this constructor, which member is initializing? Which member? This is the Y. Y means it is a static member in our application. So the private, so the constructor which is provided by the compiler, the static constructor which is provided by the compiler, initialize the static member, right? STS fields. STS field means static field, right? So which static field? The static constructor, static non-static demo. This is nothing but your namespace. This is nothing but your class name. And in this namespace, in this class, this variable is initialized by this static constructor, right? So that is what you need to remember. So here, so the code is not here. I cannot compile that static constructor, but when I will discuss the constructor, then I will explain you how it is going to execute. But for now, before executing the main method, the static constructor will be executed, and that static constructor is going to execute only once during. So number of a time you access the static members, or the number of times you created this object, the static constructor is going to execute only once, and that static constructor is going to initialize only the static member, only the static member. Non-static member you cannot initialize, right? So this variable is initialized, and once the memory allocation is done, then you can access this. If the memory allocation is not done, then you cannot access this. We are accessing this and we are getting the result as expected. It means the memory allocation is done. Who done the memory allocation? The static constructor. But you will ask, sir, there is no static constructor in our class. Yes, we do not have any static constructor explicitly. Then compiler by default will provide one static constructor implicitly. And that static constructor is going to be executed only once, and that static constructor is going to initialize only the static members of your class. Right? That's why you can see here I'm accessing the y, and y I'm getting the value 200 and 200. Now I'm creating the instance 2 times. So here I'm creating the instance 2 times. So when I'm creating the instance 2 times, that means this constructor is going to execute 2 times, and each time it execute, it will take the value 50 and it will assign this x value, right? So we will get 2 instances of variable x, right? Even if you access this after creating the instance, you will get the value as same. You will get the same 200. But here x value you will get 50. Here x value you will get 100. That means 2 different values for the variable x. Okay, let's run this application. Okay, so see, whenever you are opening the ILDSM tool, until and unless you close this tool, your application is not going to run. So I have to close this ILDSM tool. So I just close this, right? So once I close this, then only I will come to, then only I will able to run the application. See, I have closed the ILDSM tool and then it is going to run now. See, static variable y 200, static variable y 200, static variable y 200. Object object 1 x is 50, object 2 x is 100. That means the variable x is the variable x memory allocation is 2 times, and in each memory allocation, in one of the memory allocation, it is storing the value 50, and in another memory allocation, it is storing the value 100. But the number of times I am accessing the static variable, the same value I am getting. I am accessing the static variable 3 times. Even I am accessing the static variable 3 times, the memory allocation is only once. And from one memory allocation, it is sharing the data to all the instance of the class, right? So in this case, from this example class, we are accessing the static variable. If from another class, if you are accessing the static variable y, then you are also going to get the same value 200. So the point that you need to remember is static variable is going to be shared by all the instances of the class. It is going to created only once. Non-static variable depending upon the number of objects. So if you are creating the instance 2 times, that means the non-static variable is going to be initialized 2 times. If you are not creating an instance at all, if 0 instance creation is there, that means 0 times this memory allocation for the variable x will be there. But for the static variable, it is going to be created only once during the life cycle of a class. Is that clear? Yes or no?
Yes.
Yes.
So what is the scope of a static and a non-static? We have already discussed. The non-static variables are created when the object is created and destroyed when the object is destroyed. The object is destroyed when its reference variable is destroyed or initialized with null. Right? So in this case, if I write like this, so let me do one thing. The object creation is there, and okay. See what I'm doing, object, I'm just making object 2 as null. When I make the object 2 as null, then the reference to this, the object created for this memory allocation, the reference will be object 2, and this memory reference will be deleted. So you cannot access this value, right? If you are trying, then you will get an error. See, once I try, then I will get a runtime exception because the object is destroyed. So you cannot access. See, object reference not set to an instance, object 2 was not, right? The object is deleted, you cannot access. That means the non-static variables are created when object is created and destroyed when the object is destroyed. When the object is destroyed, now when the object when its reference variable is destroyed or initialized with null. So here we have created the reference variable as null. So when we assign null to the reference variable, the object is destroyed. On the other hand, static variable scope is application scope. What it means? That it means as soon as the application start and class execution start. So as soon as I start the application, right? As soon as I start the application, the static variable is created. Where is the error? Okay. So as soon as, see, I start my application. So as soon as I start the application, the static variables are created, right? The static, as soon as the static variables are created, and it will be there until the application ends, right? So the class, until your application is running, the static variables are there. Once you stop the application, once I stop the application, the static variables are deleted. But what about the non-static? Now, once you created the non-static instance, once you created the instance, the non-static variables are created, and once you delete the object, then the non-static memory allocation is going to be deleted. That is the scope, right? So the scope of application scope. So the static variable scope is application scope, and non-static scope is till the object created and destroyed, you can access the non-static. So this is all about static and non-static variables. So you can declare a variable by using the static modifier, and when you declare a variable by using static modifier, then it is said to be static variable, and the rest of all variables are non-static. You can access the static variable by using the class name, and by directly you can also access if you are accessing the variable within the same class. But from outside the class, it is mandatory to access the static variables. Static variables are created only once, right? And that is when for the first time when the class execution start. Non-static variables are created 0 or n time. If you are not creating an instance of this example class, then this variable is never going to be created. And if you are creating 2 instances of the class, then this variable is going to be created 2 times. So it's basically depend on the number of instances you created for the non-static class, right? And again, the scope, the static variable scope is application level scope. What it means? Now, as soon as your application start and as soon as your class execution start, the static variables are going to be created until your application is running. When you stop your application, then only the static variable memory allocation is going to be deleted. And what about the non-static? The non-static variable memory allocation will be done when you created an instance, and it will be there until you destroy the reference variable. Then when the object reference is deleted, and when you make the object reference as null, the object is deleted. And once you make the object reference as null, the non-static variable is going to be deleted, right? So is there any question related to static and non-static variables?
No, sir.
Okay. Now we are going to discuss static and a non-static method. The same. See, previously we have seen the example of static variable and a non-static variable. Now we are going to discuss the same thing using static method and a non-static method. So what exactly a static method? The method which is created by using the static modifier is called static method, and rest of all methods are called non-static method. Okay. Let us directly understand this with examples. See, here you can see I have 2 methods. Actually, we have 3 methods, but here I'm going to show you this is a main method. I'm not going to discuss much more related to this, because in every application you will find this main method. I'm created 2 methods. One is add method and another is mul method. You can see this add method is declared explicitly by using the keyword static. When you declare a method as static, then it's said to be a static method, and rest of all, that means if method is not declared with static, then it is a non-static method. Okay. So from a static method, how you are going to access the static member and non-static member, that we need to understand. See, this is a static block. Yes or no? This add block. So method means it's a block only. So in a static block, if you want to access the static members, then you can access them directly with the name of the variable, or you can access with the class name also. So here you can see I'm accessing the X variable, sorry, this Y is a static variable, and I'm accessing Y directly, and I'm accessing Y using the class name. We have already discussed. From a static block, you can access another static member directly or by using class name. So I'm accessing Y directly, and I'm also accessing Y using the class. And if you want to access a non-static member, then you need to create an instance of the class. See, here X is a non-static member, right or not? So if you want to access X, you need to create an instance of the class. Yes or no? So once you create the instance of the class, then only you can access the non-static member. See, so this is a static block. From a static block, you can access the static member directly or by using class name. From a static block, if you want to access any non-static member, then you need to create an instance of the class, and by using the instance only you can access the non-static. Is that clear? How to access static and non-static member from a static block?
Yes, sir.
Okay. Now come to the other method. This is a multiplication method. This is a non-static block, right? So from a non-static block, how you are going to access the static member and how you are going to access the non-static member. From a non-static block, you can access the static member directly or by using class. You can see Y is a static member. So I'm accessing Y directly, and I'm accessing Y by using the class. The way you access a static member from a static block, in the same way you can access a static member from a non-static block, right? And the difference is how you are going to access the non-static member. So you can access the non-static member by using this keyword or directly. So in previous example, we access using example, your class name. So here you can access by using the this keyword. This means it's a reference pointer which points to the current object, right? Current object means for this method is defined on which class. This method is defined in example class. So this refer to the example class object. So this example class object, is there any property with the name X? Yes, X is there. So it will access this property. Even you can access the variable directly because we are inside the non-static block. So from a non-static block, you can access the non-static member directly or by using the this operator. And from a non-static block, you can access the static member directly or by using the class. Is that clear?
Yes, sir.
Yes, sir.
Yes.
Yes, this is what I have mentioned here. Non-static to static, non-static members can be consumed only by using the object of that class inside a static block. So these non-static members can only be consumed inside a static block using the object. This is the first. Static to static. See, this is static member and this is a static block. So you can access them directly or by using the class name. This is what mentioned here. Within the same class or by using the class name. Static to non-static. Static to non-static. So the static members can be accessed inside a non-static block directly or by using the class name. Directly you can access or by using the class name you can access. This is what mentioned here. Non-static to non-static means you can access them directly or by using the this operator, right? So this is what I have mentioned here. So now let us understand. So we have understood these two method, right? Now let us go to the main method. So main method is a static block. Yes or no?
Yes.
And this add method is a static block or not?
Yes.
So if you want to access any static member from another static block, then how you can access? You can access directly by using the name, or you can access by using the class. Yes or no?
Yes, sir.
Okay, so that is what I'm saying. Add example.add and add. So both are going to work. Calling add method using class name, calling add method directly, because the add method is a static method, and a static method within the same class you can access them by using class name or by using directly the name of the method. So it is not applicable only to variable. I'm not saying variable, I'm saying member. Member means it might be a property, it might be a variable, it might be a method, right? So the same thing is applicable to method also. Now, this small method is a non-static method or not? And if you want to access a non-static method from a static block, then what is mandatory? Object creation is mandatory. So I'm creating an object of the class and I'm calling the method, right? So in this case, when you run the application, you will get the output. Right? So is there any query related to this example? Any statement which you are not understanding?
Clear.
Okay, fine. Now let's proceed to the next. See, there is also something called a constructor and a starting and see constructor and this all these things we are going to discuss in detail, right? So, but there is a concept called constructor, and even you can create the construct. You can even it is also possible to create a static constructor in your class. See, if you create the constructor explicitly by using the static modifier, then you can call that constructor as a static constructor. And if static modifier is not used, then it's a non-static constructor. The point that you need to remember is static constructor is the first block of code that gets executed under a class. In the starting, I have shown you the static constructor explicitly provided by the compiler. Why? Because we have not defined any constructor. Na? So if we have not defined any constructor explicitly, and if our class having some static data members, and to initialize those static data members, compiler will provide one static constructor. To make you understand this, what I'm doing, I'm just removing this code. Okay, I'm just removing this code. Okay, see, I'm just build the application, build succeeded, and then just open the, because this is one of the important point that you need to understand. ILDASM tool. This is the application. See, now you can see there is no static constructor. So only a constructor is there, which is not, this constructor is not preceded with the word s, and this constructor is having, and this main method is having s because it's a static block. So can anybody tell me why static constructor is not there?
No static members.
Yes, exactly. Whenever your class doesn't have any static member, then what is the need of a static constructor? Static constructor is basically used to initialize the static variables of your class. If no static variables is there, then what it will initialize? It is not necessary. That's why compiler not provide. Now please observe. Okay, let me close this one. Okay, now please observe. What I'm doing, integer y equals to 200. And I'm making this as static. Now build the solution. Okay, open the command prompt. ILDASM tool. Okay, open the project, open this. Now you can see one static constructor is there or not provided by compiler. Compiler will only provide you the static constructor when your class having any static member and you have not defined any static constructor explicitly. Got my point or not? This static constructor is only provided the terms and condition is that your class having some static data member, and as a developer you have not defined any constructor explicitly by using the static modifier. If these two conditions satisfy, then compiler will provide you the static constructor. Is that clear? Yes or no?
Yes, sir.
Okay. Now, so if you create the constructor explicitly by using the static modifier, then it's said to be a static constructor and rest non-static constructor. Okay. The point that you need to remember is static constructor is the first block of code that's executed under a class. No matter how many number of objects you created for the class, the static constructor is executed only once. We have already discussed. A non-static constructor gets executed only when you create the object of the class, right? So static constructor only once. Non-static constructor depends on the number of objects you created. And one more thing, it is not possible to create static constructor with parameter. Why? Because the static constructor is the first block of code that is going to execute under a class. And this static constructor is called implicitly even parameterized. There is no chance of sending the parameter. Let us understand this with the example. See, now my class having one static constructor. This is my static constructor and this is my non-static constructor. Yes or no? Okay, to make you differentiate what I'm doing, I'm just writing this one. Integer I equals to 10, right? So that we will not get confused. So this is the static constructor. This constructor is executed only once. This is the first block of code to be executed inside a class. And this block is going to be executed before the main method start executing, right? So before the main method start executing, before the body of the main method start executing, yeah, program execution will start from the main method. That is for sure. But before executing this body, so it will execute the static. Right? So this static block is the first block of code in your application to be executed. Let's prove this. Right? So program execution will always start from the main method, but before executing the body, so body means this section. So this section is not executed. So once it starts the main method execution body, it checks and it finds that there is a static constructor in your application. So let's execute that static constructor. So this piece of code is going to be executed, and this code is going to be executed only once during the life cycle of this example class, right? So how many times and from how many classes you use the example class, this constructor is going to be executed only once. Now let's see this constructor execution completed. Once completed this static constructor execution, it will come to this part, right? And then only the main method execution start, right? Now the number of times the non-static constructor is executed is basically depend the number of instances you created for the class. Here I have created the constructor 2 times. That means this I have created the object 2 times. That means this constructor is going to be executed 2 times. Please observe. First time, second time. Okay. So to make you feel better, so what I'm doing, I'm just giving a breakpoint here also. Okay. Executed 1 time. Come to this one. Executed 2nd time. Yes or no? So the number of times the object you created, the number of times the non-static constructor is going to be called. So what is the output? First, in the output screen, you will see that static constructor is called. Then you will see that main method is started. Then 2 times the object, 2 times we have created the object. So this constructor execution, non-static constructor is called, it will print it 2 times, and then main method execution end. That will be the output. See. Let's see the output. You can see static constructor is the first block of code to be executed, right? Then why I'm seeing this output, because we have done some mistake, because we have explicitly used this one. Okay. See. Static constructor is called, then main method execution is start, then non-static constructor called 2 times, then main method execution end. right? So the point that you need to remember is static constructor is the first block of code to be executed inside the class. Now why it is parameterless? So if I am passing some parameter, then what will happen? It is giving me some error. A static constructor must be parameterless. Why? Because we cannot call the static constructor explicitly. See, whenever I'm writing this statement, this is the constructor call statement. This statement will call this non-static constructor. But before executing the body, see, once we
Hello.
execute the body, yeah,
So like in this main method, like we have not called this static
no.
this example. So then like why it's called automatically?
Yeah, so basically, see, whenever we create an instance, whenever we create an instance, then the constructor is going to execute. And the number of times we execute this constructor, the number of times the instance of the class is going to be created, right? But why it is implicitly is because this constructor is going to be executed only once. If it allows the explicitly and it gives the permission to the user to call the static constructor explicitly, like the way we have calling the non-static constructor multiple times, then there might be chance we can also call the non-static constructor multiple times. Yes or no? If it calls the non-static constructor multiple times, what it means, the non-static members are going to be created for the multiple times. If not, static members are going to be created for multiple times. If static members are going to be created multiple times, then what is the difference between static member and a non-static member? Non-static member created multiple times, static member also created multiple times. That means there is no differences, na? So in order to restrict that, in order to allow only once the static members are going to be created, so the constructor call is made them implicitly, right?
Well,
Implicitly means they will give you guarantee that the static constructor are going to be executed only once. If they give you the access, you can call the static constructor multiple times. So to restrict multiple time invocation, they make the constructor as only once, right? So when the static constructor executed, then only the static members get memory allocation, right? If static constructor called multiple times, then static member will get multiple time memory allocation, which should not be the case. We are creating the static variable to make sure that the members are going to be allocated only once. And this is the reason why the implicit, they make the static constructor as implicit.
so
So
sir, like so it means that like static constructor will be automatically called.
yes,
Yeah, and like it will be called like once, only once.
yes, only once, yes.
Yeah. Okay.
And when the first time of this class execution start, right?
Okay.
So this class execution start from this main method, na? So once it hit the main method, so before executing the body, it will execute the static block. So we do not have any chance to send any parameter to this, right? That's why they make this constructor as a parameter less, right? Once you pass some parameter, you will get an error, because if we are passing some parameter, if we define like this, but we cannot call this constructor explicitly, na? Then if we are not calling this constructor explicitly, then how we can pass the argument or values to this parameter? We cannot pass. That's why they restricted this as a parameterless constructor. And this constructor, what is the purpose of this constructor? Whatever static data member in your class, those are going to be initialized by using this static constructor. And non-static constructor, it's up to you. If you want to initialize the data member n number of times, you can create the n number of object. Each time the object will create, the non-static constructor will invoke, and it will invoke and it will initialize the non-static member.
And so like what if we create like different the one different class which do not contain the main method, then
To make sure, so what I'm doing, so I'm creating another class
okay.
sample, right?
Yeah.
Sample one, and this class is having one constructor.
Yeah.
Okay, so what I'm doing, I'm just copy pasting this constructor, right? And I'm creating sample one. Sample one static constructor is called right? So what I'm doing, I'm creating another class, sample2, right? Sample2 static constructor is called. Let make them as public so that we can access them from outside the class, right? Right? No, you cannot make them as public because it is by default. And what I'm doing, I'm creating some other method also, right? Console, sorry, void static some method one. See, so here I'm having two classes, sample1 and sample2. This class having one constructor and this class having one constructor also, right? Let me comment, let me remove all these comment points. Okay, so the program execution will start from here. So once the main method program execution start, main method belongs to which class? Example class. So example class execution, main method execution start means which class execution start?
Example class.
Example class execution start. Example class execution start means it will execute the example class constructor, right?
Yes.
Okay, let me remove all these things, right? So what I'm doing, I'm so here example class execution start, not the sample one, not the sample. So what I'm doing, I'm invoking the sample one constructor. So sample one dot some method. So public, we need to make this as a public. So I'm invoking the sample one method first time, right?
Yes, sir. Yes, sir.
I'm invoking the same method second time. I'm invoking the same method 3 times. So even I am invoking this method 3 times. So each time I invoke this method, so which class execution is going to be there? Sample class only.
Yes, sir.
But this constructor is going to be executed only once. And when you invoke this method for the first time, when you invoke this method, this method execution will come to this part and it will check whether the static class constructor is executed or not. First time coming, not executed. So it will execute this constructor, and after executing this constructor, this statement is going to be executed. Second time you invoke this method. So it will check whether the constructor is already executed or not. Already executed, not required to execute the constructor. From the second time onward, this constructor is not going to be executed. And in this example, we have not invoked the sample2 class, any method, right? The sample2 means the class execution not started. Not started means this constructor is not going to be executed, right? So let's put breakpoint and let's debug the application.
Yes.
Right? So we don't require this. See, so which one executed? Static constructor is called the main method execution is start. That means already this constructor is called and this statement is executed.
Yes, sir.
Right? When I invoke some method one, when I press F10, so it will come. It will not come to this. It will not execute this method execution body. Where the controller right now?
The static this sample on constructor.
Right. So I click F10. So once it executes the sample one, then only it is executing the sum method one. After execution, it will come to this part. So when I invoke the sum method for the second time, does it execute the static block?
No.
That means this static block or static constructor execute how many times?
Only once.
When?
The first time when we like.
When the class execution.
When the class execution starts.
Start for the first time. And
Yeah.
does this constructor executed?
No.
Why?
because we do not use this class at this time.
Because the sample to class execution not started yet. Once you execute the sample to class, then the first time when you consume any of the sample to class member, then it is going to be executed, right?
Yeah, sir.
Okay, and one more point that you need to remember, right?
So like
Okay,
I have one more question in this, like
sure.
what if like in this like sample one class, if we do not create this like sample one constructor, then like can we call this inside the main method also, then all?
That is what I'm saying. Na? I'm not
Yeah,
calling any class member of sample two, right? What I'm creating an instance, right?
yeah.
So is this case your question whether the sample class constructor is going to invoke or not, right?
My question in this case, like it will be invoked, I guess. Yeah.
Yeah, it will invoke now because once you use the sample two means the class execution start. Once the class execution start means the constructor is 100% going to invoke.
My question is like that if we do not declare this like this constructor for this, then what will happen?
If you do not declare this one,
Yeah, just like we delete this code. Yeah, and
okay.
then we are calling this some method too.
Yeah, so if you are calling this sum method too, right? So first of all, it will check whether is there any static data member in your class. Is there any static variable declared inside the sample to class?
No.
No.
So if there is no static variables, then if you have not defined any constructor, static constructor explicitly, then the compiler will check. Is there any static constructor? No. Then
No.
compiler will check. Is there any static data member in your class? No. Then does compiler will provide the implicit static constructor in this case?
Yes, I think I should like
Why it will provide you the implicit static constructor? Is there any static data member? Is there
no,
any
no, no,
need
no,
for
no. It will
static
not. It will not provide because there is no need.
right? But if you declare like this, static integer x equals to some value,
Yeah,
right? In this case, compiler will give you the static constructor, right?
yes,
Because as a developer, we have not defined any static constructor explicitly. Then as a compiler, it's the compiler responsibility to provide you the static constructor, which is going to be invoked implicitly, right? The
yes,
body is not here, so you cannot debug it, but there is a static constructor which is provided by the compiler once the program is compiled, right? And I have already shown you with the help of ILDSM tool. Let's see this once more. So
yes.
let's build the solution, right? Now let's open the ILDSM tool. Guys, you guys are using this ILDSM tool or not?
Not now, sir.
So
Not now, sir.
try to use. This is a very important tool because once you practice now, then you will come to know many things. Because these things, so this compiler will provide the implicit constructor. How you will prove this? So only by looking at the intermediate language code, na? Because in your code you have not written any code, anything. Then how will you prove this? See. So this is static, non-static demo. So this is my sample tool, na?
Yes, sir.
See, this is CTR void. This is a static constructor, right? And he's initializing which variable? X variable. X variable is a static one. Yes, it's a static variable. So this variable is provided by the compiler. So this static constructor is provided by the compiler, right?
Yes,
Now,
sir.
and this constructor is going to be executed implicitly when your sample to class execution start. Now, if you do not have this variable, then compiler will not provide the static constructor, right? See, is there any static constructor now?
No.
No, sir.
Why? Because
We can't.
we have not declared any static data member. Na? If static data member is not there, then what the static constructor is going to initialize? It's not going to initialize anything because and one more thing, guys, here it is not required, but as this is not a static class, right? We are going to initialize the we can create the static object of this class, right? For object creation, non-static constructor is required, right? So you can see one non-static constructor is there, right? We'll discuss that in detail once we start discussing the constructors. But for now, the thing that you need to remember, if your class is not a static one, right, and if you are not defining any constructor explicitly, then depending upon the requirement, depending upon the data member of your class, you may have one implicit constructor or two implicit constructor. If your class is not a static one, and if you have not defined any constructor implicitly guaranteed to be a non-static constructor, and if your class having some static data member, then static constructor is there. That is what you need to understand.